started. So today we're going to be doing 511, which is going to be the remainder and factor theorems. So the remainder theorem states that if you divide a polynomial p of x by a linear expression x minus a, the remainder will be the same as evaluating p of a. So basically what that means is if you plug 3 into a polynomial and you get 6 as an answer, that means that if you had instead divided by x minus 3, the polynomial by x minus 3 either by long division or synthetic, you would have got 6 as your remainder, okay? The factor theorem states that if you divide a polynomial by a linear expression, then the remainder is 0, and that means it is a factor. We've already talked about that quite a bit, though. When you get 0 as a remainder, that means that it is a factor, what you divided by, okay? So let's go ahead and practice some concepts today. So we're given a polynomial, and we want to use these 4 methods to determine the value of p of 3. So we're going to use direct substitution. Everybody is familiar with this method. You basically just take p of 3. It's asking p of 3, so you're just replacing every x with 3 in the equation, okay? So you're just taking out x, throwing it out, and replacing it with 3. Now the most common mistake that I see people make in this particular topic is order of operations. You have to do the exponent before you do multiplication, okay? So, excuse me, this is going to come out to be, I have it on the wrong page. I had it done ahead of time, so I don't have to do it all in my calculator. This comes out to be 243 minus 108. So I get the 108 by doing 3 to the 3rd power, 27 times negative 4. You have to square it or put it to the power and then multiply. Minus 9 plus 4. That's going to give me p of 3 is equal to 135 minus 5. So what is p of 3 ultimately?
130.
130. So that means if we take p, a value for x, and plug it in to get the function p, we're going to get 130. So that means if you were to graph this function, at 3 for x, the y value is 130. Okay, so that's kind of how it relates to the graph and whatnot. So here's what we're going to learn today. Here's how this applies to this lesson, because I all know you know how to do this. This is where it comes into play with synthetic substitution. So what you're going to do here is you're basically going to do synthetic division, okay? Set up your synthetic division as always, and we're going to be dividing by the p-value of 3. So, when we do synthetic division, we have to put in placeholders. So if you notice in our polynomial, we're missing the 4th power and the regular x. Do you see that? So we have to put placeholders in for those. So it's going to be 1, 0, negative 4, negative 1, 0, and 4. Everyone understand how I got those? Those are the coefficients. Now we're going to do our synthetic division. Bring down the 1. My throat right now is like dying. What do we do from here?
Multiply 1 to 3.
Mm-hmm. Combine, we get. Multiply, we get.
9.
Combine, we get. Multiply, we get.
15.
Combine, we get.
Oh.
Multiply, we get 42. Bring it down. Multiply, we get 126, which gives me a remainder of
130.
130.
It is.
Isn't that as expected?
Hey, bro,
So see how instead of plugging in, you can do synthetic division, and you get the remainder as what you would have plugged in? Yes.
So, like when we did synthetic division before, with like the equation, we changed the sign. So for this one, we don't change.
Good question. We're going to see both present here. Here's my tip to you. If they give you like x equals 3, or they give you a function of, so like say they say like g of 3, that's when you just use 3. The only time you flip the sign is when it's presented in this way, like x, when it's presented in a binomial, that's when you flip the sign. Does that answer your question?
Yeah.
Okay. Any other questions about this? So now we're going to do it with long division. Everybody remember long division? So here's where what you said comes into play. When we do long division, we have to have a binomial out here. What binomial corresponds with 3? Good. X minus 3. So you always do x minus whatever that number is. And if that number is negative, minus the negative is going to become positive. Now we're going to put in our polynomial with the placeholders. I'm going to go through this a little bit quicker because the main idea for me here is just to show you how it comes out still to give us a remainder of 130, okay? So I know we've practiced synthetic or long division quite a bit. So what would we multiply x by to get to x to the 5th? X fourth. Multiply this times this. We get x 5th minus 3x to the 4th. When we do long division, we don't add, we subtract. What always happens to those first terms?
Cancel out.
When we subtract a negative, it becomes?
Positive.
Good. So this is 3x to the 4th. Because 0 plus 3 is just 3. Now we do what? You remember this? Bring down the next term. What would we multiply x by to get to 3x to the 4th?
3x3.
Good, 3x cubed. See how they're always going to line up as well? Now we multiply this times this. 3x to the 4th minus 9x cubed. Are we adding or subtracting?
Subtracting.
What's going to happen to the first terms?
Cancel out.
Good, and when we subtract a negative 9, it's going to become?
Positive.
So this is actually going to become a positive 5x cubed. Bring down the next one. What would we multiply x by to get me to 5x cubed?
5x squared.
5x squared. It's always one variable down, or one less variable. Now you're going to multiply 5x squared times this right here, x minus 3, which gives me 5x cubed minus 15x squared, and we subtract. These do what?
Cancel out.
This becomes a,
Positive.
which gives me a 14x squared, right? Bring down the next term. What would we multiply x by to get to 14x squared?
14x.
Good. Now we're going to multiply 14x times x minus 3 is 14x squared minus 42x. Subtract. Cancel. This becomes addition. Bring down the 4. What would I multiply x by to get to 42x?
42.
42 times x minus 3 is 42x minus 126. We subtract, cancel. This becomes a positive, which means we get 130. Is that what we expected?
Yes.
So, synthetic division works as well, but this is showing you that you could also write the final answer of this, which would be the quotient plus the remainder over the divisor, had they asked for that. But they just want to know what the remainder was, so you only have to put the remainder. Make sense? Why it's the same? Okay. So unfortunately, since my internet's down, I'm still going to show you Desmos as I have it already graphed, but I can't like manipulate it or play around with it or it's not going to save. So the main idea here is you can put your equation into Desmos, okay? And when you do that, you can hit the table button and you can type in 3 for x because we're doing p of 3. And what do you notice it gives you in the table as the answer?
130.
130. That also means that if I find the point, we're at 3, 130. You see how that is consistent with everything else we've been doing so far? Okay. So once again, the answer here is 130 according to Desmos. So we just learned 4 different ways to get the same exact answer. You see that?
The penultimate and then the easiest question.
This is probably the easiest. that's the one we're really going to be doing a lot throughout this. So now we're going to talk about how remaining factors work. We're going to talk about how we apply this synthetic division skills onto other things. So it says here, given x minus 3 is a factor of the polynomial, find the remaining factors and write the polynomial in factored form. Then state the solutions and solution types. So this is one of those things where you all have the necessary tools to learn to do this. You just need to put it all together. So what I need you to do right now is draw yourself a synthetic division bar. And the reason I don't give you that is because you have to figure this out for yourself. What do I need to do? So when we do synthetic division, x minus 3 is still in the form of a binomial. What's going to go on the outside here? 3. So when you're in the form of a binomial, you always flip the sign. Make sense? Now what are the coefficients going to be on the inside here?
1, 4, negative 15, negative 18.
Good. 1, 4, negative 15, and negative 18. Okay? You're going to complete the synthetic division. We don't have any placeholders. Bring down the 1, multiply. Combine, multiply. Combine, multiply. What do we get?
0.
Good. So that means that that particular binomial is a factor. So we're going to start writing its factored form out. We just confirmed that it's a factor. Okay? Now here is where things are a little tricky. This represents the constant, the linear term, and the x squared term. So this represents the polynomial x squared plus 7x plus 6, which is a trinomial. Good. A quadratic trinomial. If I were going to factor this, anybody remember how we factor these? Factors of 6?
Oh.
Good. Which are?
6 and 1.
6 and 1. So that's its fully factored form is when I have what I divided by times the rest of it factored. Okay? Now to find the solutions, you set each of these separate binomials equal to 0. Now these are easy enough that you can just do it in your head. X is 3, x is negative 1, and x is negative 6. So when it's simple enough, you can do it in your head. Okay? Everyone understand how I got the solutions there? I set each one equal to 0. Now we identify the types of solutions we have. These are all real and rational. And they all have a multiplicity of what? Do any of these zeros repeat or occur more than once? So they all have a multiplicity of just 1. They only occur once. So that means on the graph, is there any bouncing?
No.
No. That's only when you have a multiplicity of 2. Multiplicity of 3 is when you have that cubic shape curve. Okay? What do you think? Was that easy? Relatively? Yes.
How do you find the multiplicity?
Multiplicity just means, did you get x equals 3 more than once? Like, did you get that solution more than one time? We're going to do one that has a multiplicity of 2 so you can see it as well. So, this problem, they give us 2 separate roots, or zeros. Whenever they give you either 2 roots, 2 binomials, solutions, however they word it, you have to do what's called double synthetic division. So we're going to talk about how we set that up. So you're going to start it out just normal, but write it higher up so you have room to do another one below it. So you could start with either one that you want. Let's start with the 1. But you could start with the negative 2 as well, and it's not going to matter. Now inside, you're just going to write the coefficients of the x terms, like this. And I just go through and verify that I did it correctly before I go into any further, so I don't have to backtrack. And now I'm just going to do synthetic division as before. Bring down the 1, multiply. Combine, multiply, combine, multiply, combine, multiply, combine. Did we expect to get a remainder of 0 here? Yes. So here's how the next synthetic division works. See how we also have to do it divided by -2? So what you're going to now do is set up another synthetic division bar around what we already have. And your remainder is now going to be one further over than before, like this. Okay? Now, what are we dividing by this time?
2. Negative.
-2. So now you're going to do the same procedure with the -2 and see how the coefficients are already written out for you. So bring down the 1, multiply, combine, multiply, combine, multiply, combine. So had you had been given more roots, you could have kept going. You see how that works? Now here's a really important concept. You can only use multiple synthetic division when you get a remainder of 0. If you get anything except for 0, you don't want to do this, okay? It gets way too confusing. So only do this when you get a remainder of 0. Has everyone got that? Okay. So what we've confirmed is that x equals 1 and x equals -2 are both solutions of this. How did I know that? Other than that they told me.
Oh.
They both get a remainder of 0. Now every single solution is associated with some binomial. So what binomial would yield me the solution x equals 1? Not plus 1, but
X minus 1.
good. So if I set that equal to 0, I would get a positive 1. What would I set equal to 0 to get me a -2? Good. So we're not done because we still have some stuff left here. Now we don't have any more factors to divide by, so I'm going to write it out in its form. This represents its constant. This represents its quadratic term, so it's just x squared plus 1. Why didn't I put anything in for the linear term? My linear term is 0, right? So I don't have to put it in. Now, unfortunately, this doesn't factor. You know how we can do difference of squares? There's no such thing as factoring sum of squares. And you're going to see why in a second. So that's as factored as it can get. But we still have to find the solutions that come from this binomial. So I'm going to set it equal to 0. And then how can I solve this from here?
Subtract 1.
Okay, now what?
Square root.
X equals plus or minus.
I.
Good. The square root of 1 is just 1.
So.
But when we take the square of a negative, we have to put in I. So we get x equals I and x equals -I, right? So let's identify the types of solutions we have here. The first two are real, rational, right? I'm just going to say 2RR. And what are the other two?
Imaginary, irrational.
Technically, they're actually imaginary. If you were being like specific, rational, but we don't really use the word rational or irrational to describe imaginary because they're not real to begin with, if that makes sense. So you just say imaginary. But it was actually rational because the square root of 1 was a perfect square. So, do any of these, how many times do we touch the x-axis here?
Twice.
Twice, each with a multiplicity of 1. Each one only goes through once and doesn't bounce, okay? You don't have to write that, but I just want to kind of like refresh your memory on it. Does it make sense? No?
Yes.
Okay. Number 4. Everybody kind of getting the hang of the process here? So we'll do synthetic division. What goes on the outside?
2.
Good. On the inside?
1, -1, -8, and 12.
Good. bring down the 1, multiply, combine, multiply, combine, multiply, and combine. So that confirms for me that this is part of the factored form, since it gave me a remainder of 0. How would I write this out as a polynomial? What would it be?
X squared plus x minus 6.
Good, x squared plus 1x, or x minus 6. And now I have to factor the rest of this by hand. What are some factors of negative 6 that would add up to 1?
3 and 2.
Very good, 3 and negative 2. So those are going to get added into our factored form. Okay, everybody with me so far? Yes.
If it's, like, we use x minus 2 twice, so can we just write it as a square?
Yes, I was actually just about to say that. So, if you want to look like a professional, okay, you can rewrite this as squared when you get the same one. These represent the same two things, okay? I just want to show you both ways that it could be represented. So, my solutions are x equals 2, x equals 2, and x equals negative 3, right? Would you all agree with that? Why did I have x equals 2 twice?
Process it twice, so it got multiplicity of 2.
Good. So you'll often not see them write the same solution twice. I'm just showing you for like learning purposes. They'll probably just write it once, but what they'll say is it has a multiplicity of 2 at that value, okay? So these are all real rational, 3 real rational roots. And then you would just say x equals 2 has a multiplicity of 2. Does everyone understand why? Okay. So that means at the graph, does it cross the x-axis at that value?
Yes.
Yes.
It touches it, but does it cross it?
No.
No, it does what instead?
Bounces.
Bounces. Good. All right. So this one requires a factor by grouping. You remember that?
Yeah.
So I'm showing you the many different ways they can ask you the same question. I don't know if you're starting to see that, but they're saying p of negative 1 equals 0. What does that mean in context?
X equals -1.
Yes, good. X equals negative 1. So what are we going to be dividing by here?
Negative 1.
Negative 1. And are they telling me that negative 1 is going to be a factor?
No.
Something about this 0 tells me something.
Yeah.
It means that it is. Yeah, exactly. So that means that it is going to x plus 1, because that's the factor that represents x minus 1, is going to be a factor, okay? Why did I put the 0 here?
Because it is a placeholder as well.
Good, there's no x squared. Bring it down, multiply, combine, multiply, combine. You're all good with this step for the most part. Multiply, combine. So getting that 0 remainder confirms to me that x minus 1, x equals negative 1 is a solution. Now how did I know that x plus 1 is a factor? Based on that x minus 1, or x equals negative 1 is a solution. How do these relate?
You subtract 1, it's
Good. So sometimes you have to work backwards. You have to know that x equals negative 1 is representing of the factor x plus 1. Does everybody see that? You have to know how to go both ways, okay? So from here, this represents x cubed minus 4x squared plus 4x minus 16. Now, they didn't give us any other factors to work with, so we have to factor this as is. So when you have a cubic with 4 terms, I want you to split it down the middle and use factor by grouping. You remember factor by grouping? What can I factor out on the left here?
X, squared.
Which leaves me with x.
X minus 4.
Good. Over here we can take out a
4.
positive 4.
X minus 4. 4.
Good. So this leaves me with x squared plus 4 times x minus 4. That's how factor by grouping works. So we have this, and we have this. So if you ever have the sum of two perfect squares, you cannot factor that further, only the difference. So I also know I have a solution of x equals 4, but how can I find the last solution? What do I have to set equal to 0 to find the last one?
X squared plus 4.
How would I solve that?
Square root.
Eventually, yeah.
Oh.
You're right. Just we weren't. We gotta do one more thing first. Plus or minus 2i,
Oh.
right? Everybody understand why it's 2i? Plus or minus. Of course, we have the negative and the positive. So, how many of these solutions are real?
2.
2 real and rational, 2 imaginary. How many times do we touch the x-axis? Twice, each with a multiplicity of. So they both cross. What do you think? Not horrible, right?
Yeah.
Alright.
Horrible, very horrible.
Sometimes.